Hello, this is Matt Gaskill, Philosophy 160, presenting problem 8.8.3. In this problem, we're asked to show equivalence. We're given two statements, and we're asked to show that one implies the other, and then vice versa. And so the statements that we're given are this universal SAX only if SXB, and if that's our premise, that implies existential X, SAX, and SXB. So in this first tree test, we're going to demonstrate that this universal implies this existential statement. And then we'll go ahead and flip it around, and we'll demonstrate using the tree method again that the existential implies the universal. And we're also given a couple of premises to append to our tree. And so we have this existence statement that we've just copied from the book. So they've given us this existence statement. And we've also been given this uniqueness statement. So we just went ahead, lines 1 and 2, they're just copied from the book. Line 3 is just copied. It's the premise that we're starting with here, just copied straight down. And then we've got, because we're trying to show that the existential can be implied from these premises, it's the conclusion. And so we go ahead and deny the conclusion. So we take that existential statement, we just copy it straight down to line 4, and we prepend it with a negation symbol. And so that's how we get line 4. And so that's our setup. Lines 1, 2, 3, and 4 are the setup for our tree test. Now, the next thing that we have to do, in order to instantiate any of these quantified statements, the quantifier has to be to the far left of the statement. And right now, we've got this negation to the far left. And so we've got to move that negation from the left to the right of the quantification. And so we just flip the side. So we flip from left to right. And when we do that, we also swap the quantifier. So in this case, we had an existential, so we'll make it a universal. If we had universal, we would have made it existential. So when we flip that negation from the left to the right, we also swap out the quantifier from existential to universal. And then we go ahead and we just copy the rest of the statement down to line 5. And so that's how we get line 5. We just are swapping the position of the negation and then flipping the quantifier from existential to universal. And then on line 6, we're going to use line 1, and we're going to go ahead and we're doing a couple of operations here. First, we're instantiating a universal X. And so the only, we could have chosen an A or a B for our universal. We went ahead and we used an A for our universal X. We called X A. And then with the existential, though, we have to use a new name. And since A and B are already used in our tree, we go ahead and select a new name, which will be C. And so that's how we get this line 6. We're just instantiating line 1 from the universal X, setting X equal to A, and the existential Y setting Y to the new name C. And so SXY becomes SAC. So that's how we get line 6. And then in line 7, we go ahead and instantiate the universal X here. And for our universal X, we go ahead and use the new name that we just got on line 6, C. And so we go ahead and take this negated SAX and SXB, we set X equal to C. And then in each location where we have an X, we go ahead and we write a C instead. And so we end up with a negated SAC and SCB, and that's coming from line 5. Now we go ahead and we have this negated conjugation here. And so we look at our rules of inference table in the book, and we see this De Morgan kind of operation here, where rule of inference, where when you have a negated conjunction, then you go ahead and branch and you negate both the left and the right sides of the branch. And so we go ahead and branch that SAC. That's the equivalent of our circle here. And we negate that. And then we negate the right side SCB, which is our triangle here, negated SCB. In the case of SAC, a negated SAC, and we've got here on line 6 an undenied SAC. So those cancel out via lines 6 and 8. And then we've got this SCB, nothing right away to cancel it out. So we go ahead and continue with some other options here. And so the option that we're going to use right now is we're going to instantiate a line 3. And so in this case, we've got for line 3 a universal X, SAX, SXB. And here we're going to set the X to the C again. So wherever we see an X, we'll go ahead and put a C. So we've got SAC only F SCB. So that's just coming from the instantiation of line 3. And now here we've got the form where we've got this a circle only if a triangle. And so we use a rule of inference implication, which then again shows us that we need to branch. And so our circle, which in this case is SAC, we're going to negate that. And so we've got here on line 10 a negated SAC. And then the consequent is not changed. It's not denied. It's just brought straight down. Triangle comes down still as a triangle. And so we've got SCB just comes straight down. Now you can see we've got negated SAC, just like we did on line 8. And so again, we're going to go ahead and cancel the line 10 is going to get canceled out by line 6. Closes that branch. And then we've got SCB, and that gets closed out by line 8, which is the negated SCB. And that's the reason why we chose a C here when we instantiated line 3, because we were trying to get this set up. And so we can now close this branch via line 8 and line 10. All branches are closed. No, that really should have been. So all branches are closed, and so our tree indicates that this is a valid implication. So with the premises of lines 1, 2, and 3, we can, in fact, validly conclude the existential X. So now the next thing we have to do is we're going to flip these over, and you'll see we're now going to take from the existential X as a premise and then conclude the universal X. And so we're just flipping those over. Lines 1 and 2 are exactly the same as the lines 1 and 2 above, but now lines 3 and 4 are swapped. And because this existential statement is now a premise, it's undenied. And now the universal is our conclusion. And so we go ahead and we deny it. And so that's the difference there. And so we've got lines 1, 2, 3, and 4. That's our basic tree setup. And so the first thing we do, again, we can't do anything with this universal. We can't instantiate because it's not the leftmost character in our statement. We have this denial here, this negation. And so we've got to flip it over to the right side of our quantifier. And when we do that, we swap the universal for an existential. And then the rest of the statement just copies on down. And then the next thing we do is we go ahead and instantiate this existential. So we already have an A and we already have a B. So we have those names already. And with existentials, we have to use new names. So the next name that we haven't used is C. And so we go ahead and we replace X. Wherever we see X in this line 5, we replace it with a C. And so that's what we've got here on line 6, is just simply replacing the X's with C's. And then that's the instantiation of line 5, which is our line 6. And now we've got this form where we've got a negated with our material consequence there. And so we look through our rules of inference, and we can see that we have a rule for this form, the negation of implication. And it's a nice rule because it doesn't branch, it just simply stacks. And so that's why we use it early in the tree. And so if we have this negated, and then we have this circle only if triangle, and you can see in the form here, the circle just gets copied straight down, but the triangle gets negated. And so that's what we've done here. We've got this SAC, it's just brought straight down, and the SCB ends up acquiring the negation. And so lines 7 and 8 are just simply line 6 with the negation of implication rule applied. The next thing that we do is we go ahead for line 9, we're instantiating line 3. Line 3 has this existential quantifier, and so we've already used, now in our tree, we've used A's, we've used B's, and we've also used C's. So with the next name in the sequence would be a D. So wherever we see an X, we're going to, in line 3, we're going to replace that X with D. And then other than that, we're going to just copy the line down. So we're going to get SAD and SDB. And so that's how we get line 9. It's just instantiating the universal line 3. And now in this case, we've got just a regular conjugation statement. And so we'll use the rule of commutativity. And it's again another nice rule because it just stacks, no branching. And there's no negation involved. We just simply take the left side of the conjugation, write it on its own line, take the right side of the conjugation and write it on a new line. So you end up with lines 10 and 11, and those are coming from line 9. And then the next thing that we do is we're going to instantiate line 2. And we're going to do that all in one fell swoop. So we've got 3 universals here, X, Y, and Z. We could, if we wanted to, we could have X and Y and Z all be A, all be B, all be C, all be D, or whatever combination you can think of. Now, some of the things to look at, though, are we have an SAC, early in our tree. We have this negated SCB. We have an SAD and SDB. So those are they give you hints as to what combination of universals you might select. And so we ended up selecting the combination where X is A and Y is C and then Z is D. And then so we end up with, when we instantiate the uniqueness premise line 2, we end up with line 12, SAC and SAD, and then only if, and then the consequent C equals D. And then from here, we just have our regular material consequence, no negation involved. So we've got our circle, which is SAC, and we're going to use this rule of implication here. So we've got our circle, SAC and SAD, and then we've got our triangle, and our triangle is just C equals D. And so looking at the rule of implication, we need to deny the antecedent, and then we just will bring the triangle down without any kind of change. And so this is a branching operation. And so we follow our branch, we deny SAC and SAD statement. So we just bring that down and we throw a negation in front of it. And then we bring C equals D down without any kind of change. Just copy it straight down. Nothing much to do here with the C equals D for now. But what we can do is we can break up this negated conjugation, and we're going to use the De Morgan like we did in the tree earlier. So we have this denied conjunction, and it's going to branch. And when it branches, both branches get denied. And so we end up with SAC becomes a negated SAC, and the SAD becomes a negated SAD. So you got this negated SAC here on line 14, and then up here on line 7, we've got an undenied SAC. So those cancel, and then that closes that branch. Here we've got a denied SAD. We've got SAD here on line 10, undenied, and so that will close this branch here. And then what we do here is we go ahead and we use the fact that C equals D, and we look up on line 11 where the line 11 is SDB, but because we know that C equals D or D equals C, you could say it either way, that we can, wherever we see a D in line 11, we can replace that with a C. So that's what we do here on line 14, is we just replace that D with a C, because according to this branch, they're equal. They're identical. And so we end up with SCB, and if we look up on line 8, we have a negated SCB, which will then cancel out our undenied SCB down here. And that's how we close this last third branch. And all the branches are closed, and so the tree is valid. And so we've demonstrated both that you can start with the universal, and it will imply the existential, and then you can flip them, and the existential will imply the universal. All right, if you have any questions, hit me up on Pronto. Thanks.